Okay, hello ladies and gentlemen. This is Friday, and we are going to be doing a little bit more with limits today. I hope that your quiz went well. Okay, we'll talk about more limits next week when I return. Limits day 5 in your notes. This should only take about 10 minutes or so. It's actually a concept we've already talked about a little bit. It's going to be, how do we find the limit as x approaches a value for some radical functions that happen to be fractions. So for example, if I have something along the lines of the limit as x approaches 4 for x minus 4 over the square root of x minus 2. First thing you always want to do when evaluating these limits is plug in 4 for x. Maybe we'll get lucky and we won't get 0 over 0. Well, just as a spoiler alert, I don't think you'll be getting lucky too often today because I think all of these will turn out to be 0 over 0. So let's check it out. So when I plug in 4 on the top, 4 minus 4 is on the top. The square root of 4 minus 2 is on the bottom. The smartboard's shaking with some construction here, but we'll see if this works. Okay, so we got 0 over 0, which again is indeterminate, so therefore if we can't determine the limit, we have to do something to be able to evaluate the limit here. And whenever you have a radical situation like this, what I said was you want to multiply by the conjugate of whatever the radical expression is. So right now on the denominator we have radical x minus 2. We can evaluate the limit if I multiply by radical x plus 2 on the top and bottom. Okay. What I want to do is actually focus on the bottom first, and I multiply the conjugate pair. Again, I talked about this the other day. All you have to do are the first terms and the last terms, because the outside and inside parts will cancel since they are conjugate pairs. So radical x times radical x is x. Negative 2 times 2 is negative 4. So that's what we have on the bottom. Okay. Now, if you take a look at what we have on top, rather than multiplying those two binomials together, which are not conjugate pairs, I always want you to leave them separated. Okay, just express it as the product of x minus 4, and there's the value. Radical x plus 2 is the other quantity there. Okay, so now what you'll see, and this will happen in all the other examples, you can cancel those x minus 4 quantities, and now we're going to get interrupted by announcements. Okay. Okay, we're going to take a quick pause after I plug in 4 here. The limit as x goes to 4 is the square root of 4, which is 2, plus 2 is... We stand for the pledge. I pledge allegiance to the flag. Okay, we're saying the pledge. We're going to take a break. Okay, announcements are over, and we're back in business. Here we go. Number 2. We're going to evaluate the limit as x approaches negative 1 for the quantity radical 2 plus x minus 1 over x plus 1. Okay, so really quickly, you can almost do this part in your head where you plug in 0 to the top and bottom, or sorry, not 0, but in this case, negative 1 for x on the top and bottom. You're going to get radical 1 minus 1, which is 0 on top, and we're definitely going to get 0 on the bottom. So again, the way we kind of fix this is by multiplying by the conjugate of wherever the radical piece is. Okay. When the radical piece is in the numerator, we're still going to multiply by the conjugate by multiplying by radical 2 plus x and then plus 1 on the outside. Remember, the conjugate only changes the middle sign between those two terms. Don't change the sign that's underneath the radical one. Okay? So when I multiply the conjugate pairs on top, we're going to evaluate the limit as x goes to negative 1 of the first terms give you 2 plus x. The last terms give you negative 1. Okay? And remember, on the bottom, the part that's the non-conjugate pair, we leave those. We leave those as is. Okay? Okay. So then if I simplify the top, we get on the top negative 1 and 2 is a positive 1. Okay, and that denominator is x plus 1 times radical 2 plus x plus 1. And same thing that we saw before, now we can cancel those x plus 1 factors. So cancel the x plus 1s. It's the limit as x approaches negative 1 of 1 over radical 2 plus x plus 1. Okay. So when I plug in that -1 to x on the bottom, we get the square root of 1 plus 1 down there, which is 2 in the denominator. Okay. The limit as x approaches -1 here is 1/2. Although I won't show it to you too often, if you ever get stuck, remember you can look at the table, and hopefully the table can help you confirm that as x approaches -1 from the left or from the right, that the y values are getting closer and closer to 0.5 in that situation. Okay. I just have 2 more that I'd like to try. Number 3 is going to look similar to the last one. It's the limit as x approaches -3. And the quantity we're going to find the limit as x approaches -3 for is the square roots of 1 minus x minus 2. And on the bottom we have x plus 3. Okay. So again, I think what we'll see is that this is a really similar process to the last one. So if we have that radical quantity in the numerator multiplied by the conjugate, radical 1 minus x plus 2. Okay, we're going to do that on the top and the bottom. So take the limit as x goes to -3 of, multiply the first terms, you get 1 minus x. Multiply the last terms, you get a -4. And the bottom right now is x plus 3 times radical 1 minus x plus 2. So when I clean up the top of this one, what we wind up getting is -x minus 3 in the numerator. Okay? And the denominator is x plus 3 times radical 1 minus x plus 2. So remember, in order for me to evaluate the limit as x approaches -3, at this point when I plug in -3 at the top and bottom, we still get 0 over 0. So we have to be able to cancel this factor with something on the top, but those don't quite look the same. Okay? And I'm hoping that if I were to ask the question, how can I make them look the same, I would hear one of you shout out, unless it's second period, factor out a negative. Okay. So if I factor out a negative from the top, we're left with x plus 3. Now you can cancel those x plus 3s and take the limit as x approaches -3. Now on the top, since I took out that negative, we have -1 over radical 1 minus x plus 2. Okay. So when I take the limit as x approaches -3, plug that in down there. 1 minus a -3 becomes 1 plus 3. In other words, that's 4 underneath the radical. So 1 over radical 4 plus 2 comes out to be -1/4 here. Okay. We're going to do one more example. Now's a good time to remember that if you are looking outside of the crane, that you should be paying attention to limits here. Okay. All right, last one. Here we go. Last example, number 4, is going to be the limit as h goes to 0 of radical 3x plus h minus radical 3x over h. Okay. This one's going to look quite different than the examples that we've done leading up to this point, because we have 2 variables involved. We have x and we have h here. Okay. So when I take the limit as h goes to 0, keep in mind your answer in the end will still have x's in it, whereas all the other limits have been numerical in the end. Okay. So I'm going to still start this one. If I plug in 0 for h, the top is 0, the bottom is 0. Okay, so if I multiply by the conjugate of the numerator, which is 3x plus h plus radical 3x, okay, we can fix this. Okay, so now on the top, when I multiply the first pair together, 3x plus h times another radical 3x plus h is 3x plus h minus radical 3x times radical 3x is 3x. And the bottom is h times radical 3x plus h plus radical 3x. All right, so then on the top, you'll notice that we have 3x and -3x, so those cancel. So we get h over h times radical 3x plus h plus radical 3x. When I cancel those h's from top to bottom, we can now take the limit as h goes to 0 of 1 over radical 3x plus h plus radical 3x. And again, when you plug in 0 for that h on the bottom is now 1 over radical 3x plus another radical 3x. And if I have radical 3x plus radical 3x, that's 2 radical 3x's. And that's the answer. Like I said in the beginning, you're going to get something left in terms of x. What you actually did without knowing it is you just did calculus. So congratulations, you're now a calculus master. Okay? But I think that if you got stuck in any of these examples or the event that I went too fast, certainly this video will be posted to the website. I'll post a copy of these notes. So on Monday, when we all come back together, you'll have plenty of time to check in with me, ask questions before we get going on the next part of our unit here. Okay, just as a quick reminder, your test on limits and the next little piece here is going to be on Thursday next week. Okay. So I hope you guys have a nice weekend. And again, limits number 4 is for homework. Check it out, and we will go over it on Monday. And I will be checking. So have it done. All right. See you guys later.